Physical properties of alkynes. Similar ones we have talked about in case of alkanes and alkenes. So you should not face any problem. Alkynes have higher boiling point than alkanes and alkenes due to greater polarity than alkenes and alkanes. For CBSE, if you just remember this point, it is sufficient. For IIT, etc., you just need to understand why. Why I am saying that alkynes have greater polarity when these also have just carbon and hydrogen. These also have just carbon and hydrogen. In case of alkanes also, we have only carbon and hydrogen. In case of alkenes also, we have just carbon and hydrogen. So can anyone tell me why polarity will be higher in this case? Anyone? And I'm telling you, you know it. The only thing is that you will not be able to link that knowledge to explain this. If you have attended my classes sincerely, you know it. The reason you know it. Just guess. Okay, so try to understand. You remember we talked about the hybridization and hybridization, how hybridization is related to S character and how S character is related to electronegativity. S character is, Tulika, no, we won't talk in terms of inductive effect. So if you remember that, okay, we have CH3, CH2, CH3, and in alkanes, all carbons are sp3 hybridized, okay, sp3 hybridized. Means carbon will have, each carbon will have how much S character? 25% S character. 1s, 3p. So p character will be 75%, S character will be 25%. Now, if I consider propene CH double bond CH2, this is sp hybridized. This is also sp hybridized, right? Double bonded carbons. sp2 hybridized, sp2 hybridized. So in this case, S character will be 33.3% S character. This will be very much helpful to answer those type of questions where you have to arrange the compounds in increasing and decreasing order of something, maybe boiling point, okay, or electronegativity or polarity like that. Now come to alkyne. It will be like this. And this is sp hybridized, this is sp hybridized, means S character is 50%. And I told you that higher the S character, higher the electronegativity. So here it will be highest electronegativity on carbon, because carbon is sp hybridized in this case. And if you consider the Pauli's scale, okay, Pauli's scale, the electronegativity of hydrogen is, hydrogen has electronegativity of 2.2 and carbon has electronegativity of 2.55. But obviously it is not exactly 2.55. It will depend. If it is alkanes, it will be 2.55. It is alkenes, it will be slightly more than that. If it is alkynes, 50% S character, even higher, highest electronegativity. So the difference between these two, carbon and hydrogen, here, if it is 2.2 and 2.55, which is in case of alkanes, is negligible. So it does not make the bond polar. But here the difference in electronegativity, hydrogen remains same, carbon electronegativity increases, so the difference increases. So higher electronegativity, that's why difference, that's why higher polarity. Now, if the molecule is polar, in that case, there will be interaction. So if it is one molecule which generates polarity and another molecule which generates polarity, positive and negative will attract. So that's why higher boiling point, because you will need higher energy to separate these molecules into gaseous form. Is that clear? If you are not preparing for IIT, NEET, etc., you can skip. But still, I would suggest that you should know these points. Then they are lighter than water because they are weakly polar. Not as polar as water. Water is highly polar. These are weakly polar. Just because of hybridization. They are insoluble in water, but soluble in organic solvents. So we have talked about alkanes, alkenes also. They are also insoluble in water, but soluble in organic solvents. The melting and boiling point and density increase with increase in number of carbon atoms. This is true for all. Okay? Whether it is we are talking about alkanes, alkenes, alkynes, same thing. Melting and boiling point will and density also will increase with increase in number of carbon atoms. Then this is also same thing we have talked about. Branched chain alkynes have lower boiling point than straight chain hydrocarbons. Okay, so can you tell me the fifth one? What is the reason? Write in the chat box. What is the reason for fifth one? Yes, Sudhit, that is the answer. Mahi, that is the answer. Ariman, you are just telling me what is written here. Ariman, read your statement and read this statement. You have written the same statement differently. Rida, yes. Pranit, yes, it is about the less contact surface area. So when we have higher extent, greater extent of branching, there is less contact surface area. That's why lower force of attraction, lower van der Waals force. So lower van der Waals force means lower boiling point. Aditya, it is lower van der Waals force, not greater. Okay. So that is the reason. All these points are important. That's why I have written here. Okay, just in summary. So go through all these 5 points. They will help you to answer many such questions, 1-mark questions.